Okay, so this was question number 25 on the homework. First step, what would you recommend?
+1.
Okay, so we're at +1. Good so far? What's next?
Divide by 2.
Divide by 2. I feel like everybody's pretty cool with like the basic algebra. Y'all are pretty good with algebra. Then I think maybe what threw people off was the square, but maybe not. I think people knew what to do next. What do we do with the squared? Square root. Okay. Yeah, and so basically because it is a fraction, we're going to take a square root. Oh, I didn't mean to write square root. We're going to take a square root of there's two things that need to happen. I take a square root of the top and bottom when you do a fraction. Also, I think I threw this out here last time, but technically there's a plus or minus in front of it, and it's easy to forget that there's a plus or minus, but that matters because that doubles the number of solutions, because we're not just talking about the positive answers, we're also talking about the negative answers. So it's going to double the solutions. If I take the square root of the top, that's just 1, but the square root of the bottom is this. And then I think a lot of people were like, what is that? And stopped, which is fine, that's fair. But do you remember, if I rationalize this, what would I need to do? Like if I get the square root out of the bottom?
Square root 2.
Yeah. This is going to look more familiar. Does that look more familiar?
Yes.
Like for the unit circle? Okay, so the goal is here. Okay, please don't stop here. This is great. It's great that you got this far, but this is not the final answer, okay? So the final answer is actually like, what is theta? Like that's what we're trying to find. So this is like, now you're using your unit circle knowledge. So where on the unit circle does sign equal positive square root of 2 over 2? And then also negative square root of 2 over 2. It's like both of them. So where do those happen?
Pi over 4.
Yeah, pi over 4 is positive. 3 pi over 4 is also another positive one. 5 pi over 4 is the negative. 7 pi over 4 is another negative. And I can't remember the way the book was, like the way it asked the question. Did it ask for solutions from 0 to 2 pi? Okay, so I don't have to write the plus 2 pi n thing on this because it just said solutions from 0 to 2 pi. So those are that's like the list of all the solutions from 0 to 2 pi. Having seen that, does that help y'all with 26, or would it still be helpful to do number 26? What do you think? Okay. Like to do 26, or we're good?
I'm good.
You're good. Okay. I feel like 26 ended up with like the square root of 3/4. And so when you take the square root of the top and the bottom, you get square root of 3 over 2. And like that's something that's on the unit circle. Okay, so it's not too bad. Okay, so now we're going to start looking at these. And I know that last class, I feel like I had question number 3 on the board, but we didn't get to actually do it. Does that sound right? Like I think we didn't actually like discuss it. And so I'm just going to kind of like walk through, because, and y'all are going to have a lot of practice on this, okay, the rest of this week, and then also the Monday after Thanksgiving. But basically example 1 was kind of what I would call a linear example. There were no squares in it. It was just like kind of normal algebra, like straightforward. Example 2 was quadratic, but it didn't have to be factored because it was kind of like the homework problem we just went over, where we just had to take the square root of both sides. But then example 3 is going to involve some factoring, and I'll kind of give you guys some hints as far as like if you're ever feeling stuck about what to do next with these kind of things. If they have 2 different trig functions, either you're going to have to factor if you can, or you're going to have to use an identity of some sort. It's kind of like one or the other. In this case, because there's not any like extra numbers, there's no like single, just like constant numbers, this is a factoring question. But anytime you try to factor something that is an equation, what do you need to make it equal to? 0. Yeah, so that's step 1. And I would love to make sure that y'all have this written down on your paper, just because this big piece of paper should hopefully be kind of a guide as you do your practice, kind of like, okay, what kind of problem do I have you got your little spread, you know, your flow chart to help you figure out what to do. So I couldn't actually subtract 2 cotangent, so I just write it next to it. Obviously, I already gave you the clue that says like GCF, I think, or common factor. So what would you guys say is a common factor from this term and this term? Yay, then we'll have a cotangent. So if I factor a cotangent out, factoring out a GCF is like undistributing. That's not a real math word, but I feel like it makes a lot of sense. You know, you're like pulling it out of all of the terms. You're dividing. You're dividing. And by dividing, you're like undistributing it. So if I divide a cotangent out of this, I'm left with cosine squared. And if I divide a cotangent out of this, I'm left with 2. Here's the thing with factoring. We said it always has to equal 0. The reason is because anything times 0 is 0. And so it means that like either this term is 0 or this term is 0. It doesn't matter which one. And so my next step is to split it. So I'm going to have like cotangent of x equals 0 and cosine squared of x minus 2 equals 0. That okay so far? So split the factors. Okay. So again, make sure you have that if you don't have it yet. There's nothing else on this first one. So I just need to ask myself, like, where does cotangent equal 0? So cotangent is x over y on the unit circle. So let's think about it for a second. If I get 0 here, it means the numerator was 0. So where is the numerator 0 on the unit circle? Pi over 2. And then also 3 pi over 2. So there's 2 ways we could write the answer. I don't think I specified if I wanted you to write the general solution, which is the plus 2 pi n thing, or if I wanted you to write it specific. So we'll just do the general one, okay? So you could either write pi over 2 plus pi n, because do you see how if I add pi to pi over 2, that is 3 pi over 2? Yeah, so that kind of encompasses all of the solutions. But if you kind of blank and you just start listing solutions out, the reason why I can do that is because cotangent has a period of pi. So it's like I really only have to look in 0 to pi. But if you just are like, you know, in the zone, writing down all the solutions, and you happen to write both of these down, you could write pi over 2 plus 2 pi n and 3 pi over 2 plus 2 pi n. Like this is also the same thing as that. The one that's circled in black is kind of like the summarized version of this. Yeah. Now this is kind of interesting, the one on the right. So I have to do a tiny little bit of algebra to get cosine alone. What should I do here?
Just 2.
Okay. So I add 2, and then square root the 2. Technically, it's going to be plus or minus, but if we actually did square root of 2 in our calculators, we would find out decimal-wise it's bigger than 1. And if you think about the unit circle, what's the biggest value cosine ever is? Yeah, the biggest it ever gets is 1. And so this just actually is not possible. So we would just write no solution over here. So this was a case where like one of the factors gave us a solution, but like the other one didn't. I had somebody in second period ask me a really good question yesterday that I was glad they asked, because I was like, I want to make sure I say this to everybody. If we go back to the original question in the blue, he asked like, why can I not just like divide this side by cotan and divide this side by cotan, and then like cross the cotans off? And the issue with that is it actually eliminates one of the answers, like kind of unintentionally, because it's taking a factor out, and so just like completely, and so it leaves you with cosine squared equals 2, which is one of the things that we got down here, right? But like it ignores the fact that cotangent could be 0. So you actually don't want to ever divide by one of the trigs, because that's going to cause stuff to cancel out, and you're actually going to like lose solutions if you do that. Okay. Okay, so that was a GCF kind, but then number 4 and 5 were still quadratic, but not the GCF kind. apologize, this is kind of boring just to like watch problems. But hopefully it'll be helpful and then you can do practice on your own and like make the connections. We need to factor this way. This is one where like, when we did this before with trig identities and stuff, some of y'all preferred just to like drop the sign for a minute and like just look at it like this. Do you guys have a preference? Like, would you just factor it with the way it is in blue, or would you prefer to factor the purple? Blue? Okay, all right. So if this bothers you, if you look at that and you're like, that, overwhelming, like rewrite it like this and factor this one first. And then you can kind of come back to the sign, okay? So this is one where everybody has their own little method that they may have learned. I do the guess and check way generally. What are two things that are going to multiply to 2 sine squared? Okay, so 2 and 1. So I'll have a 2 sine and a 1 sine. Good so far? Okay, should we be writing this down? Make sure that we have this in all the little boxes, please. And then I need 2 numbers that multiply to give me -1. Okay. Did you have an idea that it should go in that order first, or did you like try it?
Yeah.
Or how do you think about it?
I had the idea because since sine x is negative, you have to go for the bigger negative.
Yeah.
And then so it would be minus 2x and then plus.
Yeah, that makes sense. You notice that eventually we're going to have to add to negative sign. So obviously 1 plus -1 does not give me negative sign. You know, it's like once you multiply it out, it has to add to that. And so we can always double check though. And yep, that's right. When I add those two together, it's good. Okay, but the thing is, sometimes people just want to stop. They're like, yay, I got the answer. But that's actually not the answer, because remember, I'm trying to solve. So I have factored correctly. That's great. But now I need to like actually solve it. So what do we do with our factors?
Equal to 0.
Yeah. So I'm going to have 2 sine x plus 1 equals 0, sine x minus 1 equals 0. It's just algebra, right? Like I know there's like trig stuff in there, but it actually is the same rules as you've usually done with algebra. So I'm going to solve this. I'll subtract 1. I'll divide 2. Is that good? So if I subtract 1 and divide 2, I get -1/2. Over here, I'm just going to add 1. So this has a lot of solutions, because I'm going to get solutions for each of these. Okay. Any questions so far, though, before I move on? Okay. Where on the unit circle would this sign equal -1/2?
5 pi over 6.
7 pi over 6.
Okay, so yeah, 7 pi over 6
And 11 pi
and
over
11 pi over 6. Yeah, it's the ones that are down, right? Kind of like visualizing the horizontal and then down a little bit. Yeah, so this is 5 pi over 6 and 7 pi over 6. And if I'm writing the general form, what am I going to add each time? How often is it going to repeat? 2 pi, yeah. Just a reminder, why 2 pi? What's 2 pi coming from? It's the period, yeah. So this is a regular sign. Notice there's no number next to the x. So period is still going to be 2 pi.
Wait, is it 5 pi or 1?
Oh, you're right. I'm sorry. It's not 5 pi. Yep. I said 11 pi, but then I wrote it wrong. 7 pi over 6 is good. But this was supposed to be 11 pi over 6. Thank you. I was visualizing it, but then I wrote the wrong thing. Yeah, so 7 pi over 6 and 11 pi over 6 is where it's -1/2. And then it's going to repeat every 2 pi in. Like those solutions will just repeat over and over. Now I need to do this one. This one's a little shorter. Where does sine equal 1?
2 pi over 2.
Yeah, this one, pi over 2. And I guess I'll write x equals to x equals. So this one's x equals pi over 2. And it will repeat every 2 pi in also, because again, the period of this function right here is 2 pi. And so it's just going to repeat every 2 pi. Okay, let's look at number 5. First of all, do y'all notice that this still looks like factoring problem? Because it has like a squared and then a not squared and then a number. Okay, all right, hang with me up here, y'all. But what's different about this one compared to the one before it? What do you notice is weird?
There's more variables.
But yeah, there's like more kinds of trig, right? There's 2 different kinds of trig. Okay, so here's the trick. If I'm going to factor, there's not a GCF I can take out here like I could on number 3, so that doesn't help me. So that means that I need to probably use an identity, okay? And what I mean by that is like sometimes it's as easy as it's clearly like a double angle, and you're like, I should plug in a double angle formula, you know? Which, by the way, for this test, we're going to give you a list of all the identities. Yeah, just because like the focus of the test is actually the solving, and so not necessarily the memorizing, you know? So, but here, do we have an identity that involves sine squared and cosine?
No.
Yeah.
1 minus cosine squared.
Yeah. Pythagorean identity. I mean, it doesn't, it's not cosine with, you know, regular cosine, but it is cosine squared. And now, once I simplify this, I have like all cosines. So that's actually really helpful. Okay, so that was the trick for this one, was like recognizing, oh, I need to get rid of that sine squared right there so that I can have just cosines. And so now I'm going to simplify it. I'm going to distribute, multiply the 2 all the way in. The only light terms we have are the 2 and the 3. That 2 minus 3. So I'm going to have this. That's going to just become minus 1. Okay, now I have a trinomial with a squared and a not squared and a number, and they're all the same thing. Mm-hmm. Oh, yeah, sorry, 2 minus 2. So 2 minus 2 cosine. Yeah, sorry. I forgot the 2 at first and I had to squeeze it in. So I don't know about you guys. You might be totally fine with this. And it's kind of fun. I'll just admit my like weaknesses. I struggle to factor when there's a negative in the front. It just like throws me off. Like it's still doable. It's totally fine. You can totally factor with a negative in the front. But personally, it throws me off. So usually before I factor, I like to just like multiply everything by -1. Like just so I can get rid of the negative in the front. So I would prefer to treat this problem like positive 2 cosine squared minus 3 cosine y plus 1 equals 0. So basically just like change all of the signs for my factoring situation. Yeah.
You wouldn't have to multiply to the other side since you're just taking it out. That's no?
Or you can think of it as dividing it over here. Essentially, we'd have to get rid of the -1 somehow. Yeah.
Well, I'm saying you just.
If I factored it out,
Yeah.
then I would have a -1 in the front, which would be fine. You could leave the -1 in the front and deal with it later. Yeah, you could do that if you wanted to. Okay, again, it seems like y'all don't necessarily prefer this, but I'm putting it up here in case there are people. Some people look at this and they're like, I don't know what to do with that. And I'm like, let's just ignore the cosine for a minute and think of it like this. And it's like, let's factor that. Okay. So I don't know if it helps you or not. But if I'm going to do it over here just so that I show kind of both examples, both ways of doing it. 2y squared is going to be 2y and y. Now it has to multiply to a positive 1, but I notice eventually it has to give me a negative in the middle, like eventually. So what times what is going to give me the positive 1? So it's 1 and 1. Is it going to be +1 +1 or -1 -1?
-1.
Yeah. I can do my double check thing to make sure that that adds to -3, just to be sure. That comes out to -1y. This times this is -2y. That does indeed give me -3y. So that's good. So I'm actually going to come back over to my trig now and rewrite this factored form using cosine. So it's going to be 2 cosine y minus 1, and then cosine y minus 1. So in a way, it looks really similar to the one that we just did, but it is cosine, and then this is going to end up giving me a positive number. Okay. Okay, so we split the factors. Yeah? Good? If I get this cosine alone, I get positive half. If I get this cosine alone, I get 1. What do I do at this point? What did you say? Yeah, find the y's. I need to find the y's, which are the angles, right? So that means I'm using the unit circle. Okay, so where does cosine equal positive half? Let's think. That is sine. Pi over 3. Okay, pi over 3. That's a positive. Cosine is half. And then like the one that's down here, because they need to be the ones on the left side, right? And so it's pi over 3, and it's y. So y equals pi over 3, y equals 5 pi over 3. And if I'm doing the general solution, I'm still doing plus 2 pi n, because it's, again, the period of this function right here is 2 pi. Where does cosine equal 1, positive 1? 0 or 2 pi? Yeah. You'd only have to write one of them since they tend to land in the same spot. So you could write 0 plus 2 pi n, or you could write 2 pi plus 2 pi n. So here's all the solutions. Show. So 5 pi over 3 is in the fourth quadrant where cosine is positive, and then pi over 3 is in the first quadrant where cosine is positive. Yep. Okay, y'all, that's kind of as complicated as a factoring problem can get. Like having to change it to Pythagorean identity first, like, and then eventually factoring, okay? So then we have the big theta questions, which we alluded to in the last lesson, like they kind of came up a little bit. And this is number 6. Again, I'm just making sure my matches. Yeah. How did you guys feel about these? Slash, did you get to these?
No.
Okay, that's fine. Let's do it together.
Well, I got to this one. I got a little.
Okay, let's do it together. Y'all yell out steps to me. What's first?
Plus 1.
Okay.
Love it too.
Yep. Okay, y'all with me? Okay. Here's where I don't want you to divide by 3, not yet, because the cosine is on the outside. We have to deal with the cosine first. This is the problem that I call the big theta question. You really don't have to do this if this doesn't help you. But again, for some people, it's like they kind of get thrown off by that 3, and they like try to incorporate it like too soon into the problem. And so really at the very beginning of the problem, I could have been like, oh, I see this stuff in here. Let me just call that theta for right now, and like just solve everything with theta for the moment. So this is saying at what angle is cosine a half? We actually just did that, didn't we?
Yeah.
So cosine is a half at pi over 3, and cosine is a half at 5 pi over 3. Okay, so I have just solved for theta, but I haven't actually solved for t yet. You know what I mean? Okay, so it's like I've gotten rid of the cosine. Now I need to find the t. And so here's where I would be like, okay, 3t equals pi over 3, and 3t equals 5 pi over 3. And then if I'm solving it for t, what do I need to do? Yep. And dividing by 3 is the same thing as times a third, if that's helpful thinking about fractions. So this gives me t equals pi over 9. And then this one, when I divide by 3, I get t equals 5 pi over 9. Okay, we need to be a little bit careful here. So when we do the addition part, it's not plus 2 pi n this time. Why is it not plus 2 pi n?
The period is short.
The period is shorter. I've divided it by 3. I've squished it. So I think it's helpful here, like that was a 3t, to kind of like think about what the period is. Remember how period is 2 pi over b? So what's the period in this case? 2 pi over 3. Yeah. So you would just be like pi over 9 plus 2 pi over 3 n. So it's repeating every 2 pi over 3 now, instead of repeating every 2 pi. Just because the period, like the wave was squished. And so here I would also write plus 2 pi over 3 n, because it's going to repeat every period. Cool. So on number 7, if you want to add parentheses around the x over 2, just to kind of show that, like, hey, that's the argument, okay? Do y'all like the big theta, or do you just not, or do you not need the big theta? How do you feel about it? You like the big theta? Okay, okay. So I'm going to go ahead, just because that looks kind of weird, I'm going to go ahead and put a big theta right there. Okay, just treat that like a theta. What's the first step? Very good. So I have 3 cosine theta equals -3, and that's just so much nicer to look at, right? And then I divide by 3. Okay. All right, I'm going to do that kind of quickly. So, okay. -3, divide by 3. Unit circle time, once you have the trig alone. So where does cosine equal -1? Yep, over here at pi. So what I have just discovered is that theta equals pi. Okay? Because if I plug the pi in here, that will give me -1. All right? But of course, I'm not trying to solve for theta ultimately. What am I trying to solve for ultimately? What was the variable? Yeah, it was x, because it was an x in there originally. So now I replace this as x over 2 equals pi. And one last time. What do I need to do? Times 2. So x equals 2 pi. And then we need to be careful with our addition here. It's not plus 2 pi n. There's a couple ways I can think about it. If you want to think of that as 1/2, the period is basically 2 pi divided by b, which is 2 pi over 1/2. Also, you can think about it as like whatever you have to do here, you're actually also going to have to do like to the period, you know? So what am I going to add instead of 2 pi n? Yeah, 4 pi n. Because that's what the new period is going to be. Beautiful. Anybody who went to the bake sale is in like a sugar coma moment, probably.
So confused how it's so cheap.
I know, right?
50 cents.
Yeah. I made that cookie cake too, actually. Yep. I made the cookie cake.
It was good.
All right. Okay, y'all. What do you notice? Tell me what you notice. Like what stands out to you? They're different. I have a cosine and I have a sine. So one thing is that the trig is different. What else is different?
Placement.
Yeah, the placement of the two. This one has on the outside, this one on the inside. So the thing that's on the inside of the trig is called the argument. Okay, so they actually have different arguments. Like this one has 2b and this one just has b. That is a really big problem. It makes it really hard. Like solving just the way this is like not really going to happen unless you can make the arguments the same. So when they have different arguments, it's like we need to use a trig identity. So do we know a trig identity for this? Double angle. I know it was last week, and it was a lot to memorize. Does anybody remember the sine of 2 theta?
2 sine,
Uh-huh.
v times cosine.
Yay! Okay, yeah, okay, so that's the, and again, y'all are actually gonna have a formula sheet on the test with the identities. So you won't have to stress about having to memorize all of those, yeah. Just because, it's just a lot to memorize, you know. I feel like I want you to know them like for the test, but then I'm not trying to test you on your memory for this, I'm trying to test you on solving. So, any ideas from here? This actually now looks like a problem they've already done. Yes, it's like the factory thing, the like undistributing, yeah. What do they both have? They both have cosines. This term and this term both have cosines. Okay, so a lot of people didn't have this problem done yet, so I should see you guys writing in, okay? We should be filling this in. So this has a cosine, this has a cosine. So I take the cosine out, and I have 2 plus, actually I can take a 2 out too. Do you want to take a 2 out?
Yeah.
Wait. You can, you don't have to. It's not going to actually change anything, ultimately. But if I divide this by 2 cosine, I have 1 left over. Sometimes people just make it totally disappear. But it hasn't been subtracted, it's been divided. So like 2 divided by 2, cosine divided by cosine, like that's going to be 1. Okay, what's going to be over here? What's left?
Sine.
Yeah, just a sign. Now it is factored, which is lovely. So we split our factors, set them both equal to 0. Okay? Good so far?
Yeah.
Now it's actually relatively straightforward. It's not that bad of a problem. If I divide both sides by 2, I just get cosine equals 0 here. I'm going to subtract 1 on both sides. So I basically need cosine to be 0 and sine to be 0. So where on the unit circle is cosine 0? Pi over 2 and 3 pi over 2. I'm being a little bit lazy here and writing the comma, but that's fine. What's the period? Yeah, it's just 2 pi. And I'll put 2 pi in because it's going to repeat every 2 pi in. The reason it's 2 pi is there was no number next to the v here. And so it's just going to repeat every 2 pi. And then where is sine 0?
Is it sine -1?
Oh, it's sine of -1. Yes, thank you. I wrote -1 here, but then I didn't actually do it. So it's not actually sine equals 0. It's where does sine equal -1? Where does sine equal -1? Yeah, 3 pi over 2, which coincidentally was actually already one of our answers. So I could write it again, but I had 10 if they don't have to write it again. Okay, it's like just repeating. Okay. So first of all, I kind of want you to talk to your groups for a second. You don't have to like actually work the whole thing out, but can you, and let's go ahead and put this in parentheses. I know they weren't there. Let's go ahead and add that. Can you talk with your group real quick? What do you notice and what identity do you think you're going to have to use? So here we go. What did you notice? What stood out to you? What was kind of weird? The half angle. Yep. So what identity do you think you're going to have to use? A half angle. Yeah, a half angle. I know that like there is a square here, so you might be thinking Pythagorean, you know, but it's going to be actually more helpful for us to do the half angle. But good news, the half angle has a square root sign in it, which is ugly, but there's a square here, so that's going to make it better. Okay, yeah. This is really, honestly, I feel like this is like as complicated as it can get. This is like the most intense these problems can be, which is not that bad. So let's see. So I'm going to replace this with the half angle. It's technically plus or minus, but because I'm going to square it, that's going to end up going away. Because when you square a positive, it gives you a positive. When you square a negative, it gives you a positive. So the plus or minus is going to go away. But do y'all recognize that formula? I know it's been a week. But the squared and the square roots are going to cancel each other out. Okay? And so we're gonna get 1 plus cosine squared x equals 2 times 1 plus cos x over 2. So you see how I just kept everything the same, I just got rid of the square root. What do you see now as far as simplifying? Yeah, these 2's can actually cancel out, which is lovely. It actually ends up not being too bad. So the square roots canceled out, and then the 2's canceled out. I'm noticing that we have a cosine squared and we also have a cosine, which is kind of an indication of what, like what's going to end up happening. Factoring. That's kind of like your indication. It's like a flag or something like, oh, I've got a squared and a not squared. Like I'm probably going to have to factor. So if I'm going to have to factor, what do I have to set it equal to?
0.
0, just like algebra. Okay, so I need to set this equal to 0. I'm going to move this, the right side to the left side, just because I like leaving the squared positive. But conveniently, the 1's go away, because I'll subtract 1 and that goes away. And then I'll subtract cosine. So I'm going to have cosine squared x minus cosine x equals 0. So this is actually not too bad because I don't even have to do a trinomial thing. What kind of factoring do I have to do? So GCF. Yeah, I'm going to have to factor out a GCF because they both have cosine in them. Okay. So I factor out a cosine. If I divide a cosine out of this, I'm left with a cosine. If I divide cosine out of the second term, what am I left with?
1.
Yeah. Okay. This is feeling really repetitive at this point. Do you guys agree? Like, it's like the beginning of it was different, but like a lot of these have ended in factoring, set them both equal to 0, solve. Yeah. So I'm going to have cosine x equals 0, cosine minus 1 equals 0. This is going to be cosine of x equals 1. And now I use my unit circle knowledge. You do still have to know the unit circle. I'll give you all the formulas, but I do still want you to know the unit circle. So where does cosine equal 0? Pi over 2, 3 pi over 2. We've done that. And this is x technically, like these are the answers for x. The period is 2 pi because there was no number here, so I just write plus 2 pi here. And then where does cosine equal 1? Yeah, 0 and 2 pi, so you could just write one of them down. And then I do the plus 2 pi in. We did it. That wasn't actually that much of a booger. It starts off looking really ugly, but it ends up not, like so many things cancel that it ends up actually being kind of nice.